So you may be wondering if scientists have this common language that they can speak when referring to organisms and specific species and whatnot. How do they organize these 8.7 million species that we know to exist today? Well, there are these things called dichotomous keys that help scientists do this. So, what is a dichotomous key? A dichotomous key is a tool that taxonomists use to help them identify organisms. What this is that they're paired yes or no questions based on physical traits there. That is, once again, the physical characteristics or traits to help identify an unknown organism. This also, not only in naming organisms, this also helps taxonomists determine if the species that they're currently looking at is something that is new or has already been discovered. And the reason why it's called dichotomous is because it's divided into two parts. So a dichotomous key will always have two paired statements that will help scientists determine the species they have in front of them and be able to figure out what specifically it is. So there is a plethora of dichotomous keys out there for you to use if you happen to be on a walk or if you are at the aquarium and you're wondering what type of species you're specifically looking at, you could use for known developed species. But it's also an interesting task to make a dichotomous key. And so this video is going to describe for you how to do that. I will also tell you that this hyperlink up here where it says how to make a dichotomous key, that's a hyperlink. If you go to the slides resource that I have in the Google Classroom, you will notice that there is a link there that you can watch. And there's a teacher, it's not me, but it's a teacher who walks you through step by step on how to create a dichotomous key. I've taken that video and kind of broken it down further into step by step. So there really is a specific way to create a dichotomous key in order to make sure that it is successful and can be used by others. Because ultimately, that's the goal. As a taxonomist discovers a new species, they create these dichotomous keys so that any other individual would be able to follow their key that they've created in order to get to what type of specific species someone may be observing. So there's several steps. Let's start now. So the first step is to set up a list of paired statements. So notice over my example over here to the right, if you look at this example, you can notice that there are paired statements. So there are two statements, and they're usually labeled 1A and 1B, or A and B as you continue to go down. So they're paired statements. And you will look at your organism and you'll decide what the characteristics are that the dichotomous key is describing. Now, you might be wondering, because you will be in charge of creating a dichotomous key, how do you even know how many paired statements you start with? Well, what you are going to do is you are going to first start with the total number of organisms you have before you, and you're going to take that total and subtract 1. So the number of organisms minus 1. So, for example, if I have 6 organisms that I'm trying to create a dichotomous key for, I would have 5 paired statements because we are all math geniuses and we know that 6 minus 1 is 5. The thing that you have to do when you're creating these paired statements is use the word has or no to start your paired statements. Obviously, you're going to need to reword as needed. So you can look at my example. It doesn't say has or no, but external shell present, you could say has external shell or no external shell, right? That could be a way that you could reword it. The key thing is don't start identifying right away. So in your first pair of statements that you have there, notice how 1A, if there is an external shell, you're going to go to step number 2. If there is no external shell, you're going to go to step number 3. There is no species identified in that first step there. You want to separate organisms into two groups based upon, once again, physical characteristics. So that very first step, that very first number that you have in your dichotomous key, pick a physical characteristic that will quickly separate the organisms you have before you into two very distinct groups based upon their physical characteristic. So just to kind of further extrapolate upon that, so notice how 1A ends with go to 2. and 1B ends with go to 3. So once again, you're not giving me a species straight off, but you are giving me two very physical, distinct characteristics that I can easily then separate my organisms that I'm looking at. And in this example, you can look over here. We have several invertebrates over here. So if it has an external shell present, like B and C, that's where you're going to go to number 2. If it does not have an external shell, like A, D, or E, you're going to go to step 3. So, for example, if I'm trying to figure out, say, what if I were attempting to figure out what organism D is, for example, I start with statement 1. External shell present? No, there actually is no shell present in organism D. So if I says external shell not present, I'm going to go to step 3. So I completely skip step 2. It's not relevant. I go to step 3. At step 3A says distinct head and tentacles present. Well, I can see a head and tentacles, but I should read 3B just in case. It says distinct head and tentacles not present. Well, there's definitely tentacles, so I'm going to go to step 4. Now, step 4 is either the first one is rounded head or 4B is torpedo shaped head. In my opinion, this is more of a torpedo shaped head. So this organism, letter D, belongs to the order Teuthiida. So remember, it goes kingdom, phylum, class, order. So I would even need a further dichotomous key to figure out what organism the species is from. So just a reminder, I know I kind of went a little bit deeper with a dichotomous key in this, but how you make a dichotomous key is that the very first step is to set up the number of paired statements you're going to need. So if I have 6 organisms, I'm going to do one less paired statement. So 6 minus 1 is 5. So I'm going to have 5 paired statements. That's step 1. What do I do next? The next thing is you list the traits. Now remember, in step 1, you are figuring out how many statements you need, and you are also then creating one physical trait that will easily separate your organisms into 2 groups. Like remember that example was has an external shell, doesn't have an external shell. So that easily separated those organisms into 2 groups. So after you've done that, you're going to then thinking about listing the traits of the organisms that you have left. So, good traits to use would be like physical features, something that is very objective, like black fur, ears as big as its head. Remember, not saying, keeping things very specific and statements that are true all or most of the time. The bad things that aren't really helpful in a dichotomous key are things like a location. So, if you say that this organism is found on a rock, well, what if that species at one point in time is found in the middle of the forest floor on the dirt, right? So that wouldn't be a great trait to give on a dichotomous key. Or maybe even its behavior. You can't observe that if you're looking at a preserved specimen, for example, or even an image of a specimen, right? And don't give me the classification. So don't tell me that it's an insect or things like that. Those just really don't help when I'm looking at a bunch of unknown organisms. In addition to that, you don't want to give me subjective traits like this gross bug or this ugly fish. Those things are very subjective and hard to tell. Similar to like small or big or light or heavy, all of those things are really open to a vast amount of interpretation. The key thing here is that assume that whoever is using the key has very little prior knowledge of any animal. So that's why I'm saying not to include the classification. Us at this stage know what an insect is, how that's different from, say, a fish. But we can't really assume that when you're making a dichotomous key, especially when you get into unknown organisms. You don't know maybe what area of classification they fit into. So just try not to include that in your dichotomous key. So that's the second step is to list the traits that you have. The next thing is you want to choose a one broad trait to separate the groups into, like I mentioned. So, for example, fill 1A and 1B in with this trait. So, like it has 6 legs or it doesn't have 6 legs. It will easily take the insects that I've included in this picture, in these pictures, and separate them into 2 groups. It's easier to do this after you have already come up with a list of physical traits that the organisms have. Think similarly to some of the activities we've done in class, where we brainstormed characteristics that things have such as color, size, texture, shape, things like that. And then you're able to make the dichotomous key going forward. It's just a little bit easier. So start first with that one trait that will separate these into different groups. So you can see my images of my insects here. I can easily take a look at these examples and I can see that I have 3 insects that have 6 legs and 3 that have more than 6 legs. So, but once again, sticking with the has or no, or does not, present or not present, those kinds of things. So I've taken my 6 insects that I have before me and I have already divided them into 2 equal groups. So after I have created that first set of statements that will group my organisms into 2 separate categories, the step 4 is to choose another physical trait to divide that very first group. So the first group that I had that I said has 6 legs. This is what my step 2 is going to be. The thing is, if you're down to one organism, you can put that name outright. So if I only have one organism left, that's the name of the organism. For example, if 2A has a metallic shine. So if you look at the 3 insects that I have here, the thing that's most obvious to me, the difference between these, and to kind of further classify these insects, is that the the Carolina tiger beetle has a very shiny metallic shell to it, right? It's exoskeleton. So if I said my first one for step 2 with 6 legs, if I said go to step 2, 2A has a metallic shine, that automatically eliminates my other 2 6-legged insects, and now I have the Carolina tiger beetle. However, my other 2 insects that I have left don't have a metallic shine. So now I'm going to go to step 4. So that's how I would write that dichotomous key. The key thing is here is that if there's still more organisms left, or if there's still a group of organisms left, so 2 or more, like in this example, I have the 2 insects that are still left, I would write go to 4. That's where this comes in with after 2B, because I need to now go on to further classifying those 2 insects that are left. So hang tight because we're almost done. So, what is the step after I have kind of figured out and keep going until I have specifically identified each organism that I'm trying to classify? So, you continue with paired statements until all of the organisms have been identified. And then after you do that, you need to check yourself. Go back and pick any of the organisms you have before you that you've created the key for and see if it works. The last thing that I would really suggest you do is give someone else your dichotomous key and see if they're able to do it. Because remember, that's the whole point of a dichotomous key that taxonomists have developed, is so that anybody else, if they were to come across an organism, they might be able to figure out and using the key to what type of specific species it is that they're observing. So now that we've discussed the 6 specific steps on how to create a dichotomous key, let's practice. We're going to use the wonderful clip art pictures that I provided below of the hummingbird, the penguin, the owl, and the duck. So we all know from our previous knowledge that what these birds are, right? But if you didn't, you could create or follow a dichotomous key. And this is a good way to practice. So the first step you need to do when you're looking at this, remember, step 1 is how many paired statements am I going to write? Well, how many organisms do I have before me? I have 1, 2, 3, 4. Remember that we start off with the total number of organisms minus 1. So 4 minus 1 is 3. So I'm going to have 3 paired statements. So on a piece of paper, I would write 1A, 1B, 2A, 2B, 3A, 3B, and 4A, 4B. Oh, I'm sorry, we would stop at 3B. Sorry, you would stop at 3B because there are 4 organisms. The next thing I would do is I would need to look at some objective traits that could be used to classify these organisms. Well, can't say they're birds because they're all birds. Can't say they have beaks because they all have beaks. Maybe their color, maybe the fact that they have different types of footing, maybe that they fly or don't fly. Those are things that we could use to classify these organisms, right? And you look at some physical traits too, like we just did with looking at in terms of their footing, maybe if they can fly, their color, those types of things, the shape of their beak, all of those things could work. After I've done that, I need to think of a physical trait that I could just divide the first group. So if I have four of these, if I look at this, the thing that kind of is really obvious to me is the webbed footing, right? So I'm looking at if I do has webbed feet, doesn't have webbed feet. And that categorization allows the penguin and the duck to be put over in one spot, and then the owl and the hummingbird to be put in another spot. And I'm going to just keep going until all of the organisms have been identified. And then you need to, like I said, check your work and have someone else review it. So we're just going to follow the 6 steps that I've described in the previous slides and practice it. So here we go. If you look at this, remember we said we would have 1A, 1B, 2A, 2B, 3A, 3B. So the physical trait that I selected was has webbed feet. So if it has webbed feet, the person's going to go to step 2. If there's no webbed feet, they're going to go to 3. So just notice how it goes in chronological order. Basically, your first group is going to be your even numbered of steps, and your second group, your B group, is going to be your odd number of steps, unless you've identified the organism, correct? So 1A has webbed feet. So let's say, for example, I am trying to identify what this beautiful organism is right here. Okay, I'm not sure what it is. So I'm going to use this dichotomous key to figure that out. So has webbed feet. Nope, it doesn't have webbed feet. It has no webbed feet. So according to my dichotomous key, I'm going to write go to 3. Let's go to 3. 3A has tufted feathers near its ears. Nope. Has no tufted feathers ears near its ears. So that means that it's a hummingbird. So how did I write this? How did I do it? Is basically kind of what we need to take a look at. So if I say it has webbed feet, I'm going to say go to step 2. Now, when I'm writing the dichotomous key, if I'm going to have 2A and 2B already written down on my piece of paper. I look at my 2 webbed feet organisms. Well, what's the biggest difference there? Well, physically, the biggest difference to me is the color of their belly. So I can say 2A has a white belly. Now, one of the two is only going to have that, right? So it's a penguin. And I'm left with 2 organisms here. So I really do need to be describing what specific type of species it is. 2B, since it doesn't have a white belly, is going to mean that it's a duck. So now I am done with my webbed feet group because I have identified the species or the name of these 2 organisms. I know I didn't use scientific names here, but we're just practicing, right? So for the organisms, then I go back up to see what I had for 1B, which is no webbed feet. So I've already written 3A and 3B, and I look at my 2 non-webbed feet birds. And I look, okay, well, what is the biggest difference there? Well, looking at the feathers where their ears are. So the has tufted feathers near its ears. Since I only have 2 organisms now, I do need to identify what they are. That's an owl. And the other physical difference has no tufted feathers near its ears, which is a hummingbird. So remember, the key thing that I want you to look at our practice here is that we started with the number of paired steps of our organisms minus 1. We set it all up already on our paper, 1A, 1B, 2A, 2B, 3A, 3B. And then we went through in our first set of paired statements and separated our organisms into 2 separate groups. And then from there, we further categorize them going down. The key thing is that it's paired statements, and we're looking at physical characteristics that are concrete and easily observed. I hope that this practice has helped you in identifying on how to write a dichotomous key, because get ready, we're going to practice.